We know that before we represented the real numbers in the coordinate axis. This is the coordinate axis. This is the coordinate axis. From here to negative infinity, here to positive infinity, and here is 0. Here 1, 2, 3, up to infinity. Here -1, -2, -3, up to negative infinity. This point here by 0 is known as the origin. The coordinate of this point is 3. The coordinate of this point is 3. Again, this is known as the coordinate axis. It is known as the real number line. So we know what is the real number line right now. This is the origin, this is the coordinate, a point, and corresponds to a number. Every real number, 3, 4, 5, -1, every real number corresponds to a point on the number line. And every point on the number line corresponds to a real number. Okay, this is for you to know. Now, if this person walks this way, okay, and he stops here, how many units did he walk? Okay, you will say that he walked 1, 2, 3 units. 3 units. Units, it could be miles, it could be kilometers, meters, centimeters. We don't know. Units, therefore we say units. If it is not mentioned miles, kilometers, or miles, or centimeters, or whatever, we mention he walked 3 units. Notice that we went from to the left. Okay, you didn't say he walked -3. This is wrong. You can't say he walked 3 units. Okay, what about this person? This is 1 unit, 2 units, 3 units, 4 units. Then he walked 4 units. Okay, units are maybe miles, maybe kilometers, maybe centimeters, we don't know. However, he walked 4 units. So the distance is always a positive number. You cannot say he traveled -3 units. You never ever. You can't say only he traveled 3 miles, 3 kilometers, 3 centimeters, 3 units. Okay? Now we will discuss the absolute value and distance. The absolute value is like this. The absolute value, for example, of 3 is equal to 3. The absolute value of -3 is equal also to 3. Okay? So, the absolute value of a real number called A, okay, is denoted like that. What do we mean by the absolute value? It is similar to the distance. You have here the coordinate axis or the real number line. Here we have the origin. Here we have 1, 2, 3. Okay? 1, 2, 3. So the absolute value of 3 is the distance between 3 and the origin. Between this and this is the distance, which is 3 units. Also, for the absolute value of negative 3, it is the distance between negative 3 and the origin. What is the distance from here to here? It should be 3 units. The absolute value of a real number called A is the distance between A and the origin. Is the distance between A and the origin, which is 0. Okay? On the real number line. If we say like this, we have here 0, and we may have here, for example, A, and here we have negative A. The absolute value is the distance between A and the origin, or negative A and the origin. If we are interested to know what is the definition of the absolute value in math, okay? Let's take first examples. What is the absolute value of 5? It is equal to 5, right? The absolute value of 0 is the distance from 0 to 0, of course, it is 0. What is the absolute value of negative 5? Is what? Also 5. We are interested in finding the absolute value definition. Definition of the absolute value. The absolute value of A equals what? The absolute value of A can have two portions. First, if A is greater than or equal to 0, that means if A is positive or 0, then we have the same number, right? So it is A. And we have different number if A is less than 0. So we have negative A. What we have done here to be 5, we took negative what is inside, which is negative of minus 5, to get 5. So this is the definition of the absolute value. Again, this is an explanation. If we write it again for you to understand, definition, the absolute value of A can take two values. It is A if A is positive or equal to 0. It is negative A if A is less than 0. Or what can you say? Another way to say, if A is negative. If A is negative, so we take the negative of it. If A is positive or equal to 0, we leave it as it is. Like this example. If A is positive, it remains the same. If A is 0, it remains the same. If A is negative, we take the negative of it, which is negative of minus 5. Then the answer is 5. So, it is negative A when A is negative. Positive or remain the same if A is positive or greater than 0. That's it. Again, the absolute value of A is a if a is greater than or equal to 0, negative a if a is less than 0. That's it. Let's take an example to understand. If an example comes as simplify, for example, simplify. The absolute value of x minus 3 plus the absolute value of x plus 2, given that x is greater than or equal to minus 1, less than or equal to 2. Solution. Please recall that the absolute value of a equals a when a is greater than or equal to 0, negative a when a is less than 0. How to solve this question? Okay, we are interested in knowing that is this value positive or negative. If it is positive, the absolute value will stay there as it is. If it is positive or 0, the absolute value will stay as it is. If it is negative, we will take the negative of the negative. So we want to know whether x minus 3 is it positive or negative or equal to 0. We are interested in knowing that. Okay, so to check, what we are going to do is by trying numbers. We are having this interval. Okay, let's say it is represented in the number line as this 1 2, here 2 closed, here negative 1 negative 2, here 1 closed. So x can take all the values here. Okay, so if we try numbers for x, negative 1 0, you can take 0.5 also, but we will simplify things. So negative 1 0 2. We would like to check in this domain we have, or in this domain for x, checking. So if x here is minus 1, this value is minus 4. If x is 0, x minus 3 should be minus 3. If x is 2, x minus 3 is minus 1. Given that x is greater than or equal to negative 1, less than or equal to 2, we know that x minus 3 found from here is negative in this. What about x plus 2? Okay, if we check here x, we take the same value, minus 1 0 2. So x plus 2, if x is here minus 1, the answer is 1. If x is 0, the answer is 2. If x is 2, the answer is 4. So we know that x plus 2 is positive. So we know by default that the absolute value of a negative number is the opposite. So the absolute value of x minus 3, because it is negative, so equals to negative of x minus 3. Then if we simplify it, it should be 3 minus x. Okay, and the absolute value of x plus 2 will remain the same because it is positive, x plus 2. Of course, this one could be written as minus x plus 3. So to simplify in the question, the absolute value of x minus 3 plus x plus 2 equals minus x plus 3 plus x plus 2. Combining x's together, they will go, so the answer should be 5. We simplified everything. Another example, if I tell you to simplify, or I'd say write without the absolute value, it is the same. The absolute value of x plus 6 plus the absolute value of x plus 5, given that zero is less than x and x is less than 1 open. The solution, again, we are interested whether this is plus 6, whether this number is positive or negative or 0 in this. Okay, the same, we are interested whether this number is positive or negative or 0 in this. Why is that? Because we know that the absolute value can have two different values. It can have a if a is greater than or equal to 0, or negative a if a is less than 0. Therefore, to check whether this value x plus 6, is it positive or negative, in here we have here 0 and we have 1, here open, okay, here open and here open. You cannot say that like before you took 0 and 1. This is wrong, because 0 and 1 here open, not closed. If it is closed, okay, you can take 0 and 1 values and check. However, they are not closed, they are what? Open. Therefore, we will check with one number between them. Let's say 0.5. 0.5. 0.5 is here. Is here. So we can check. 0.5 is 1 over 2. So what is x plus 6? If we take 0.5 or 1 over 2, here it should be 6.5. So it is positive. What about if we take x and the other value x plus 5, checking that 0.5. So if we take 0.5, it should be 5.5. Then it is what? Positive. To simplify, x plus 6 equals x plus 6 will remain the same in the x is greater than 0, less than 1. Also, x plus 5 will remain the same. So the absolute value of x plus 6 plus the absolute value of x plus 5 equals x plus 6 plus x plus 5. So adding x together should be 2x. Then adding the constants together should be 11. As simple as that. Suppose that I change the question the same as before. The absolute value of x plus 6 plus the absolute value of x minus 2, given that x is greater than 0, less than 1. The same question, however, we have here x minus 2. So we know that always the absolute value of a is positive if a is greater than 0, negative a if a is less than 0. So we will never take the values of 0 and 1. We will take something between them, which is a number 0.5, for example. So here if I say x and I tell you here 0.5 and checking what is x plus 6 here and what is x minus 2 here. X plus 6, if we check 0.5 should be 6.5, which is a positive number. If I put here 0.5, then it should be minus 1.5, so it is a negative number. And x is greater than 0, less than 1, the absolute value of x plus 6 will remain the same. However, the absolute value of x minus 2 equals the negative of what is inside, because we know that it is a negative value here. So the negative of x minus 2, which is equal to minus x plus 2. So to simplify, the absolute value of x plus 6 plus the absolute value of x minus 2 equals x plus 6, we know that, minus x plus 2. So x and minus x will go together. Then we have 6 plus 2, which is 8. And we are done.